Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is optimal array, and it is a medium level problem. So the problem statement says that we have been given a sorted array. So we have to note that this particular information is very important, that the given input array is already sorted of length n. Right now, what we have to do is we have to print some answers for each index from 0 to n minus 1, and for each index what we have to do is, for example, if we are at the ith index, we have to make all the elements from 0 to I equal, right? For example, if you are at index 1 and you have the elements 1 6, you have to perform some operations such that both of these elements are equal, and the minimum number of operations should be written in answer of I or answer of 1, right? So this is our problem statement. Now let me just show you an example. So if this is the input, and like if you have only one element, right, starting element, obviously you don't have to make any change, so the answer would be 0, right? Now we have two elements. What we can do is I can change either 6 to 1 or 1 to 6. For example, if I change 6 to 1, then the number of steps required would be 5, right? Now if I have the first three elements 1 6 and 9, I can change all three of them to 6. So this will take me 5 steps and this will take me 3 steps, so the answer would be 8. And if I have all the four elements 1 6 9 and 12, I can change all of them to 6. So this will take 5 steps, this will take 0 steps, this will take 3 steps, and this will take 6 steps. So the answer would be 14 here, right? So this is how the problem is working. Now a very important observation, or rather a very important fact that you need to know for all problems of these kind where you want to make all the elements equal, and remember it only works in a sorted array. So for example, if you have some elements a1, a2, a3, a4, a5, you want to make them sorted, right? They are already sorted and you want to make them equal. So what you can do is you can just make them equal to the middle element, right? Remember that the array should be sorted, only then this would work. You can always make them equal to the minimum middle element, and this would require the minimum number of steps, right? This is a very important fact, and I also read it in a book called CP Handbook, which is available on the CSES website. I don't remember exactly on what page it was written, but this information was present in that book. And you can always in a sorted array, you can always make all the elements equal to the middle element, and this way you will require the minimum number of operations, right? So if you have observed previously, when I was explaining that, even when I was explaining the test cases, I was always making them equal to the middle elements. So for example, if there were four elements, if I do 4 by 2, or rather if I take 0 based indexing, I'll do 3 by 2, so I'll get to 1th index, right? So I'll have to take care of this particular thing, that the floor value is taken, and I can take this particular value. So essentially what is happening is, I'm at each step I'm taking the middle element, and I'm trying to make all the elements equal to the middle element. Now this part is very clear, that I can easily take the middle element to minimize the number of steps. But how do we actually calculate the number of steps required to make all the elements equal to that middle element, right? This is the trick part. So for example, if I have 1 6 now, I have recognized that I want to make it equal to 1, that is my middle element in these two numbers. I want to make it equal to 1, but how do I know how many steps do I require to, like uh, make it equal to 1? So one way of doing this is like traversing through the array and calculating the difference of 1 minus a of I, right? So this is the let it be x. Let us not take any value here. Let it be x here. So the next time you include 9, again you will have to do the same thing, x minus a of I, and this time you will have to traverse the whole array again. Again similarly with, let me write it here. So when you have 12, you will have a new value of x, and you will have to traverse the whole array again. So this process overall would take O of n square time, right? But this is not like, this will give us TLE definitely, and this would not be applicable. So like how do we do this in O of n time? The problem is this. So to do this is in O of n time, there is a very neat observation in this particular problem, and that is once you have already calculated the answer for example, two values, the first two values. So for the first two values, the answer was 0 and 5, right? You don't need to calculate it again for all the values. You just need to calculate it for the latest values. For example, when I include 9, I just have to calculate the answer for 9 and I can use this previous result which I have already generated. Why? Why this always works, I'll show you, and this is a very interesting thing that you will see. So when they were only 1 and 6, right, what I was trying to do is I was trying to make them equal to 1, and this element was requiring 5 operations and this element was requiring 0 operations. But when I included 9, what happened is, let me just not talk about the latest value. Let me just first observe what changes are made in these previous two values, right? Let us just observe this particular thing. Now when I have included 9, my middle element becomes 6 and I want to make them all equal to 6. But what will happen is, now in this case I'll have to change or add 5 to this value and I'll have to change nothing in this value. So you see, overall change is still the same, that is equal to 5. It's just that they have rebalanced among themselves, right? You have to listen to this thing very carefully, that the previous elements will always rebalance themselves automatically. You don't need to compute them again. The number of steps that will be required for the first two elements will always be equal to 5, right? And now since I want to add this particular 9 also to the list and I want to make them all equal to 6, so what I'll do is I'll take the previous result plus I'll add the number of steps required to make this particular change for 9. So in this case I want to subtract 3 from it such that it becomes equal to 6 and the total number of steps required would be equal to 8, right? Now the last element was 12, so I want to add 12 to, right? So in this case, the answer will be 14. Now let me just add one more element so that the middle element changes. Because after adding 12, the middle element is still 6. So I want to change this also, right? So let me just write it again. And I'm just trying to give you one more example of this thing. So now my middle element is 6. I have to increment this by 5. No change in this particular element. I have to decrement this by 3. Decrement this by 6. So the total sum is equals to 14. Now if an element, for example 15 arrives, right, and I want to make the middle element equals to 9, right? So the middle element would be equal to 9. I want to make all the element equal to 9. So what I'll essentially have to do is I'll have to increment this particular value by 8, this particular value by 3, this particular value by 0, and this particular value I'll have to subtract 3 from it, right? So if you observe, if you just mod it and add, so this is 6, 3 plus 3 is 6 and 8 plus 6 is 14. Similarly, if you do this here, what you will do is 6 plus 3 is 9 and 9 plus 5 is 14, right? In both of the cases, the answer is still the same. It's just that the elements have rebalanced them among themselves, right? So the values have changed, but the overall sum is still 14. It's still the same. So I just have to compute what change do I need to make in 15 so that it is equals to 9. So I can subtract 6 from here and I can add 6 to my answer. So it will be equals to 20, right? So this is the important observation that you need to make. So let me just quickly discuss the problem once again. I'll explain you from the start. So what I have is, I have an array of elements. In any array, when it is sorted, if you want to make all the elements equal, it is always optimal to take the middle element. This is a fact, right? You need to know this particular thing, that if in a sorted array you want to make all the elements equal, the most optimal choice is to choose the middle element. Now that we already know that we want to choose the middle element, how do we actually calculate the number of steps required to perform this particular operation? Now, if we traverse going through all the values, since we know I want to make my value equals to x, and I can find the total number of operations I need to do on this value, I can compute it by doing absolute of x minus a of I for each of those values. But if I try to do it again and again, the overall approach will be O of n square. And I want to optimize it up to O of n, right? So what I essentially do is I just observe this particular thing where I know whenever I'm including a new element, what happens is if the middle element changes, the elements try to rebalance them among themselves such that an individual difference I want to make might change, but the overall sum of values is still the same. If I have already computed for 1, 6, 9 and 12 and the middle element was initially 6 and when I include 15, the middle element changes to 9, the answer does not change because the new element that I am taking is still from the same list and it is present inside the list. So on individual level, the answer might change, but if I take them as a group, the whole thing, the answer does not change or the value does not change. So what I can do is I can reuse this value, answer of I minus 1. So I can compute my answer of I as answer of I minus 1 plus some new value which I have just computed, and this new value would be equals to like the latest value minus the middle element which I want to make all the elements equal to, right? So I just have to do this particular thing. So this would be the solution for today's problem. Now let me just show you the code. Although the code is very simple and there's nothing to show it in, but let me just discuss this particular code what I have written. So what I've done is I've created a vector answer of size n and initialize all the values with 0. So you don't need to do this. It's just that I wanted the first value to be equal to 0 because the answer for I is equal to 0 would be 0, right? And starting from index 1 to less than n, what I just do is I calculate the latest answer, what the change I want to make to the latest value, that will be equals to absolute of a of I minus a of I by 2, right? Now my answer of I would be equals to answer of I minus 1 plus x, and at the end I can just return the answer. So this problem was fairly simple to code, but it's just a few observations that you need to make that makes it a medium level problem. So this was it for today's video. I hope you guys were able to understand and I hope you guys were able to derive some value from this video, and if you did, then you can show your appreciation by clicking the like button, and you can subscribe to this channel. I'll be posting these kind of videos regularly. If you are enjoying and if you are able to learn from these videos, you can definitely subscribe. It's always free of cost, and at any time later if you don't like the content, you can always unsubscribe later. So till the next video drops, keep coding, stay safe, bye bye.